So we are going to be identifying roots, x-intercepts, and zeros, given graphs. So if you look at that paper I gave you, that's where all the graphs are that we're going to be using. But to start with, we are going to look at this graph up here. You don't have it. Okay, so we're not on the paper yet. We're just looking. We're not writing anything down. Okay, if we look up here, can you tell me what is the name of this graph? A parabola, right? You used that a lot last year. That's the main graph we focused on. Okay, do you know another name for a parabola? This quadratic. You know a quadratic? Okay, so it's a parabola or a quadratic. Next. What'd you say? Is there another name? Not that I know of. Okay, I have, what is the parent equation for this graph? Do you know just the parent equation? X equals what? Yes, the formula, the parent graph. Y equals not mx plus b. That's a very different kind of graph. Do you mean A, parentheses, x minus h squared plus k? Yeah, do you remember doing this last year?
Maybe.
Okay, so this tells us our key features.
Oh, yeah.
Okay. Okay, so this, yes, I'm glad that you remember this. We'll be using this in the next couple weeks. So last year you did quadratics. This year we do cubics, cube roots, square roots, all kinds of other higher degree functions. But the one that I'm really looking for is y equals x squared, right? That's just our basic parabola, okay? So we're going to be focusing on just the basic ones today. But yes, y equals a times x minus h quantity squared plus k is something that we will use. Yes? You don't have to write this part down yet. No, we're just talking about the parabola for now. Now, what points or coordinates are considered important for this graph?
-1.
Sam? -3 and 1. What do we call those? X-intercepts. Do we agree?
Yes.
Remember talking about those last year?
Yes.
Okay, so that's right here and right here. Any other important points? -1. Comma -4. What is that called?
The y.
This is the axis of symmetry. That is called, the point itself is called the vertex, okay? Remember talking about those last year? Do we have any other points we might need to know?
The
Maybe this one right here?
yeah.
What's that one called? The y-intercept, okay? So if I have all of that information, can I graph it or write an equation from that information? Yes, you might have to do some math, and I will obviously have to reteach you how to do it, but you have the knowledge or you have the ability to do it once you remember how to do it, okay? So I want you to look at your paper real quick. Do any of those look like this graph? On the side that has half of it blank, we're looking at 1 through 4. Do any of those look like this? No, so a parabola has a vertex every time, right? It either has a maximum or a minimum value. Do our graphs on there, do they have like an obvious vertex or anything to see like that? No, so we're probably going to have to find some other information. Do they have any of these other key features though? Yeah, what do they have? They have x-intercepts and, yeah, some of them have obvious y-intercepts. Some of them don't quite go through the line, but if we extended the graph, we could see them, okay? So, on your paper, so in your notebook, this is going to go into your notebook for today. I need you to make a table, but this only has 2 rows. Can you create one that has 5 rows for me, please? We're going to fill in the rest of it as we go on, okay? Okay, so we're going to first start with our most basic graph that you already learned, which is linear. Do you remember linear? What does a linear graph look like? It's a line, right? And what is the equation for this one? Y equals mx plus b. Okay, so our line or our linear graph is y equals mx plus b. And I hope you remember that as we get into second semester, because last year was rough when we had to graph lines. I had to teach it 3 times. So m is what? What does m stand for as our reminder? Slope. And what was our b value? B was our y-intercept, okay? So can you fill that into there? Okay, so we have our linear function or our line. And then in the graph portion, you can sketch a graph of it, okay? So our sketched graph might look like this. That's our line. Okay, and we're going to skip the degree for now. Now, what was the graph we just looked at, the one we focused on last year in IM2? A parabola, or what was the other name we gave it? Quadratic. We're going to call it a quadratic, okay? And what did we decide that the parent equation was? Not with all the key features, just the most basic one. Y equals, that's with all the key features. What is it? Y equals x squared. So the one that you have, we'll work on in a couple weeks, okay? So our basic, most easy quadratic equation is y equals x squared. That will just give us the idea that it looks like the u. So can you sketch that graph too? We'll put degree right now. So if you look at our quadratic parent equation, what is the exponent on x? What is the exponent for our quadratic? It's a square. So what do you think the degree is? What number is that? What number is the exponent? What is this number? What's that number? 2. So what degree do you think it is? Second degree, because the exponent is 2. So we have a second degree polynomial. Our quadratic is a second degree because it has its highest exponent is a 2. So then what do you think the linear degree is? First degree, because x, the exponent is a 1. Okay, so we have our second degree and our first degree polynomial. Okay? Any questions about that so far? Okay, can I move on now? And if you miss something from here, we're going to keep filling in the rows so you can catch it on the next slide. Okay, now we're on the paper that I handed out. On the left side, there are some vocabulary words. Do you see what I'm talking about? Okay, what's the first word? Roots, then what? X-intercepts, then what? Zeros, then what? Factors, and then solutions of f of x. Okay, so our first one is roots, but that's not the first one we're going to write. Our first one on here is actually x-intercepts. Okay, so that's the coordinate where the graph intersects the x-axis, and you all were able to tell me where that was. And the way we write that is x comma 0. It's a coordinate pair, x comma 0, with x being the number where it goes through the x-axis, okay? Can you write this definition down and then highlight, box, circle, draw attention to how we write an x-intercept? So you can highlight written as x comma 0. After our x-intercepts, we have roots. So this is the x point where the graph intersects the x-axis. So our x-intercept is the point x comma 0. The root is just whatever that x value is, the number where I go through the x-axis. And that is written as x equals number, however many roots that I have, okay? And then finally, I have zeros, which are equivalent to roots. So zeros and roots are the same thing. They just have a different name, and I'll call them by both names, okay? So zeros are also written as x equals number, comma, for however many that I have, okay? And I want you to highlight how we write each of those different things so you know, because that's what we're practicing today. We're going to move on. I'm going to show you a graph right now. It's not on your paper, so we're just going to talk about what's up on the board. Okay, so I have a graph right here. What do you notice about it? What kind of information can I tell? Yeah, it's kind of wavy. It's a little bit more wavy, maybe like a snake than a parabola. What else can you tell?
It intersects twice.
It intersects the x-axis how many times? Twice? 4 times. Okay, where does it intersect the x-axis? At -3, 0. Where else? -1, 0. And 2, 0. Okay, so maybe my 4th intersection would be a y-intercept. But we're not worrying about those right now. We'll talk about those, some more in the following weeks. But how many x-intercepts do I have? I have 3 x-intercepts. So on my quadratic, how many x-intercepts did I have? On the quadratic, remember right here. How many times did I go through the x-axis? Twice. And what was the degree of that polynomial? Okay, so if I have 3 x-intercepts, what do you think that degree is?
Third degree.
Third degree, perfect. Okay, so our next row is going to be a third degree polynomial. And what do you think that equation is going to be? Y equals what?
Y
Equals x cubed. Good. So if I have y equals x cubed, what do you think the name is going to be? Cubic. So I have y equals x cubed. This is called a cubic graph. Okay. And this is what it looks like. It looks kind of like a snake. It has to go through the x-axis 3 times. Make sure you notice that. Okay, so for our linear first degree, it goes through the x-axis once. Quadratic second degree goes through it twice. And then cubic third degree goes through the x-axis 3 times. Okay, so we have our cubic. So now what I want you to do is we're going to look at the first 2 graphs on the paper that we have, okay? So it says list the roots of the function below for number 1, and number 2 says list the zeros of the function below, okay? So I'm going to give you about 30 seconds in your group. Talk about what do you see, what does that mean, and how will you write this answer, okay? So talk in your groups, and I'll come around. What about this now? Okay, so number 1, it says list the roots of the function below. How do I know how to find a root?
You have to. It's every time that it goes over the x.
Yeah, my roots are everywhere I go through the x-axis. So how many roots do I have for number 1?
3.
Goes through the x-axis 3 times. Where does it go through the x-axis?
1, 2, and 3.
At 1, 2, and 3. And then I heard a few of you say that there is no y-intercept.
Well, there is.
In the picture, there's not.
There is. You just we don't see it.
But if I extended the y-axis down probably like to the, bottom of the projector screen, and the graph would like keep going infinitely, it might, eventually go through the y-intercept, okay? So we will figure out how to find that in the next few weeks, but for right now we're just focusing really on x-intercept, zeros, and roots. So you told me that my roots are at 1, 2, and 3, right?
Yeah.
So how do I write the roots?
X equals.
X equals, what's my first number? 1, 2, 3. There you go. That's how you write the roots. That's the answer. Okay. Number 2 says list the what?
0.
Zeros. So where are my zeros at? Every time I go through the x-axis, zeros are the same as roots, just a different word for them. So where are my zeros for number 2? -4, -1, and +5. So how do I write the zeros? X equals
-4.
-4, -1, and +5. Is that okay so far? Not too bad? Okay, it's easy.
Don't say that.
It will stay easy. We'll keep going over it. Okay, next. My next slide is going to be 3 and 4. So graphs 3 and 4 on your paper. Do these graphs look the same as 1 and 2? No. What do we notice instead? Yeah, there's like more intercepts, right? Or it goes through the x-axis more times. On number 3, it says list the roots of the function below. How many roots do I have? I have 1, 2, 3, 4. So what is it? This is a 4th degree polynomial, okay? So if it says list the roots, how am I going to write that? What are my roots? X equals -3, -1, 1, and 3. Is that true? Are those my only roots? And then finally on number 4, it says list the x-intercepts. So how do I list the x-intercepts? Am I asking for roots and zeros this time? No. So how do I write x-intercepts? -3, 0. How do I write my next one? -2, 0. -1, 0. What about my next one? +1, 0. And my last one? +2, 0. Does that make sense? Now, if I asked you for roots on this one, right, I would just write x equals -3, -2, -1, 1, and 2. So literally, I take the x value, and that is my root. That is my 0. okay? That is my solution. That's another word that we call it, okay? So we're going to go back to our table. So what do you think is going to go in these last two rows? Fourth and fifth degree, okay? So on the first one, it was a fourth degree because I had 4 intercepts. What do you think that equation is going to be? Y equals x to the 4th power. And the name of that is quartic, like in quarter. Okay, it's called a quartic polynomial, a quartic graph. Okay, it's quartic. Can you say that? Quartic. Okay, it's not quadratic, it's quartic.
Sure.
And it looks like this, kind of like a W. Looks a little bit like a W. Bless you. And then in my last row is 5th degree. So what do you think that equation is? Y equals x to the 5th power. And the name of that is quintic. Quintic, like quintuplets. Quintic. And that graph looks like the cubic, but it needs to go through the x-axis how many times? 5 times. Okay, copy that down. Okay, we have 2 more vocabulary words to fill in, yes? What is the first one? Factors. Do we remember what factors are? Yes, when we factor our polynomial, it's like x minus 3 times x plus 3 times x plus 4 or something like that, right? So our factors are written this way. So when we're given a root, the factor is going to be the opposite sign. So if I have a root of x equals 3, what would the corresponding factor be? So this is x equals positive 3. So remember when we were doing solutions? I have to set it equal to 0. So I get x minus 3 equals 0. So what is the factor when I have x equals 3? What is the factor when I have x equals 3? The factor is x minus 3, okay? So if I have a positive root, my factor will be x minus the number. When I have a negative root, the factor will be x plus the number. So remember last week, we were starting with x minus 7, x plus 5, whatever our factors were. And you guys were like, switch the sign, switch the sign. Well, now we're just going to kind of work backwards, okay? The other way is you can subtract or add, so we can get our factors equal to 0. But that's how we're going to solve it, okay? So our solutions of f of x, those are our roots or our zeros when we solve the factor. So fill that in. I don't have a slide for that one. But the solutions of f of x are the roots or the zeros when we solve our factor for x. Our solutions of f of x are the roots or the zeros when we solve our factor for x. Solutions of f of x, roots or zeros, when we solve our factor for x. Okay? Can we move on now? Okay. We're going to go back to 1 through 4. We're not on the back side of the paper. That's what we're doing next week. We're going back to 1 through 4. And now we're going to write the factors. Okay? So on number 1, my roots are x equals 1, 2, and 3. How do you think I'll write those as factors? X minus 1, x minus 2, x minus 3. That's factored form. That's the factored form of that polynomial. You just gave me the equation by reading the graph. Okay, on number 2, what is that one? X plus 4, x plus 1, x minus 5. What about on number 3? X plus 3, x plus 1, x minus 1, and x minus 3. Do we all understand where that's coming from? Okay, so I got x plus 3 because it's the opposite sign, x plus 1, x minus 1, and x minus 3. Okay, now on the last one, do I have roots or zeros? No, what do I have instead?
X plus 3.
What's the name of these though? X-intercepts. So I'm still just going to look at these numbers, and that will tell me what my factors are. So what's my first factor? X plus 3. What's my next factor? X plus 2. X plus 1. Then what? X minus 1 and X minus 2. Okay, do you understand how I got those factors from the root zeros and intercepts? Okay, we have 3 minutes left. I have one last slide for you. This is going to go into the blank part of your sheet, okay? So, on the right side of what you just did, okay, is going to be this last part. So I want you to kind of split it in half because we're going to make 2 separate columns to compare. On the left side, you're going to draw a degree 2 polynomial and label it. On the right side, a degree 3, label it. Back to the left is a degree 4, and the right is a degree 5. So I'll give you about 30 seconds to sketch this real quick, and then we'll talk about it. Drawing. But let's talk about this. If you look on the left side over here, what do you notice about both of those degrees? What kind of numbers are 2 and 4? They're even numbers. So what do I notice about the right side? They're odd. And what do you notice about the graphs themselves? You see anything about their end behavior? Positive does go up in either way. But what do you notice about the even ones? They go... You're showing me your arms both up, but what does that mean about their direction? They both go up, which means they're in the same direction, okay? So our even degree polynomials go in the same direction. Since these are both positive, it goes up. Could they both go down? Yeah, on a different kind of graph. And our odd degree goes in the opposite direction, okay? So please include even and odd degree in your notes. That's the last thing that we're going to do today.